Assalamualaikum warahmatullahi wabarakatuh, and a good day. So today we will be presenting about our IoT mini project, GPS tracker for delivery, shipping, live up ETA updates. So our team member is Muhammad Afiq bin Muakal and myself, Muhammad Hafizul Amin bin Hashim. So for introduction, our project background is the rapid evolution of technology has redefined the landscape of transportation. So prompting the need for innovative solution to address emerging challenges, this IoT project stems from the recognition that the current transportation system lack real-time visibility, leading to inefficiency and customer dissatisfaction. So the integration of IoT aims to revolutionize the sector by providing accurate and timely information, enhancing the overall efficiency of transportation domain. So next, the problem statement that we get is in the current transportation system, the lack of real-time tracking capabilities result in operational challenges and delays. So this project seeks to address this issue by introducing an IoT-based GPS tracking system that provides precise real-time ETA updates for enhanced transparency and operational efficiency. So there's manual tracking and sorting, which causing efficiency and the item that going to be delivered, and the lack of tracking if item already being sent out. So next, our primary objective of this project is to develop and implement an IoT-based GPS tracking system that offer accurate and real-time ETA updates, and to develop a system that will be able to help to smooth the delivery process and item offloading, and this to make sure that the item will be successfully delivered to the correct location. So for IoT system definition and boundary, so this IoT-based GPS tracking system proposed in this project will be encompass a network of GPS tracking device deployed in transportation vehicle, and the system boundary include the entire transportation process from departure to final delivery. And it will provide real-time information on the location and ETA of shipment, contributing to more transparent and efficient transportation system. So next, this is our control system flow process, where at first we will unload the item from the store, and then set the destination on the device. The third step is live tracking, where when the delivery process is ongoing, and then after arrive to the location, we will offload the item, and lastly we'll show the completion of delivery on user interface. So for system requirement, hardware requirement. So this is our physical prototype and the connection. So we are using first our using controller, which is ESP8266 Wi-Fi to control all the sensor. So we are using Neo 6M GPS sensor for location tracking, and RFID sensor reader to read the RFID tags, RFID tag used by warehouse, and RFID card used by consumer or store. So next, Afiq.
I will continue the explanation. So we have a interface that we have developed. So this interface is to provide a user-friendly experience for both customer and logistic. and it will also provide the time and also ETA update on the navigation. So this is the sample of the user interface that we'll be accessing. Next, we will show the demo from the product, uh, where we including the coding. So this is our Arduino coding. So we are using the ESP8226 Wi-Fi, and we also include the SPI, RFIC, WebSocket, and tiny GPS. So we have set the configuration for the Wi-Fi, and this is to connect to our own Wi-Fi. And this is the RFID tag that we have declared. This is for the tag, and the second one is for the kite. And we have declared the pin accordingly, and WebSocket is using 81. So this is the socket that we use for the GPS. And we have declared all the coding in the Arduino and push it into our controller. So after we push the controller, this is the serial monitor that we received. So from this recording, we can see the Wi-Fi is already connected, and the IP address of the server is 192.168.168.201. Then this coding is actually integrated with our HTML, and on the HTML, actually we are using Apache, and this Apache is installed inside the Docker desktop. This is the coding for the Apache, which we show the result from the RFID tag and also the geolocation. Let's continue on the web GUI that we will going to access it. This is the web GUI that been set. This is the display. As you can see, this is the current location where the blue color is highlighted, and the end is the destination, which we put the Kuala Lumpur, and the duration estimate time is 14 minutes. This is the estimated time. Then this is the delivery status for the RFID. Once we tag our RFID tag, the tag just now is as per mentioned by Hafizul, the tag will be used by our warehouse. So once the item is loaded into the lorry, and the warehouse tag the RFID in the lorry, sorry, because I need to refresh the page. So again, this is when we tag the destination, it will show the estimated time. And then when I tag the RFID, item on board and ready to be delivered. So the status of the item is already ready inside the lorry. This is tagged by the warehouse to make sure that the item is already onboarded into the lorry. Then once it's arrived to the destination, the store or the consumer or the user will need to tag by using the CAG that we have provided. So the CAG itself, when we tag, it is saying the item is already delivered. This is showing that the item is already received by the user, and based on the coding, because we only have a two guide, based on the coding, if any other guide that tag into the RFID, it will show not a valid tag. So it will request a valid tag to be tagged into our RFID. So that's how we control to make sure that the pair is a valid pair. Then from our interface also, we have a navigation that's shown. Then from this navigation, it can be used to set the path that we need to take to reach the destination. That's all from our side, and that is the product that we created for our mini project. Thank you.